So question 11 says, find the real solutions of the following equation by factoring. So again, when it says real solutions, we're looking for whole number math, negative whole number math, fractions, decimals, positive negative numbers. So anything that's real out there right now is what we're looking at. So let's see what we come up with for this one. Now let's start with this. This is a degree 3 equation. A degree 3 equation is described as cubic. So if it's a degree 3 equation, it can have up to 3 solutions. It can have up to 3 real solutions, or actually say 3 solutions. We'll get into the other part of that later. So if I rewrite this equation, x cubed minus the 16x squared plus 63x is equal to 0. Notice that we can set this equal to 0. So I can say x cubed, well, we already got set equal to 0. So what we can do is try to factor this. Hold on. Let's back up here. So what is our set equal to 0? Come back here. So since the set equals 0, our next step is to actually factor. Notice that this does have a GCF in them. So notice how there is an x in common with all 3 terms. So I'm going to factor the x out. If I pull one x out, that leaves me 2 x's here. If I pull an x out here, that's going to leave me a minus 16x. And if I pull the x out there, that's going to just leave me this 63 is equal to 0. So notice that we now have a monomial times a trinomial, but this trinomial is actually quadratic. And notice how the coefficient of the x squared is a 1. So this means this quadratic is still factorable. So we have this x, and then since this is has a coefficient of 1 in front, we know that we can just set up our 2 sets of parentheses. We know the x has got to go here and here, but the catch is, what are the factors of the 63 that give me a negative 16? So that's my question is, what are the factors of a 63 that give me a negative 16? Again, if you're unsure what the factors of 63 are, you can go y equals, you can clear this off, and you can type in the 63 divided by x, and it'll make a table for you. So if we go to the table, we can kind of see that we want to start with 1. So 1 times 63 would be good. 2, no. 3 times 21. No 4, no 5, no 6. 7 is 7 times 9. And then 8, no. And then I think 9 times 7 would be the other one, yeah. It's just flipping. So we have those pairs there. Which one of those is going to give me a 16? It looks like 7 plus 9 is 16. Let's double check that. So 7 plus 9, that is 16. But to get a negative 16, they're both going to have to be negative. So a negative times a negative. Does a negative times a negative still give you a positive? Yeah, we know that a negative times a negative is a positive, so that still holds true. And negative 7 plus negative 9 would be a negative 16. So these would be my last 2 numbers. So we'd be putting in then a minus 7 and a minus 9 here. So this side actually has 3 factors. So I set each factor equal to 0. X equals 0, x minus 7 is equal to 0, and x minus 9 is equal to 0. Now this is already solved for x, but notice how I got to move the 7 to the other side. X equals 7. I'm going to move the 9 to the other side, and that's going to make that become then a positive 9. So that would be my 3 solutions, 0, 7, and 9. So 0, 7, and 9. That would be your 3 solutions.